Okay, we're going to cover 3.3 system word problems. We're going to cover rate, time, and distance problems and rate, time, and work. Our formula for these problems are rate times time equals distance. And we have a couple different situations. We could have something like this where we have two things going in the same direction for the same distance, then the distances are equal, or where you're going somewhere and then turning around and coming back, those distances are equal. So set them equal to each other. We also could have ones like this where they're traveling in opposite directions, or they're traveling on, they stop and then they travel farther, where we need to add the two distances. So we'll start with a picture each time to kind of give us an idea of how to set up our equation. But the basic idea will always be rate times time equals distance. Let's look at this first example. I got Melanie left the city traveling at 58 miles per hour. So I'm going to put M here. She's going 58 miles per hour. Well, at the same time, Jessica left the city going in the opposite direction, 51 miles per hour. Find the time they traveled before the two were 199 miles apart. Okay, so let's think about what we have here. We've got one girl traveling one direction, one traveling the other, and we want to know when their total is 199. Let's see. Their time is going to be the same because they're leaving at the same time. And we want to know when their distance together is 199. So we have, for this distance, we have the rate times the time. So her distance would be 58t. Jessica's distance would be her rate times her time. So we're going to have 51t. And we want to know when those two together will equal the 199. So my equation is 58t plus 51t equals 199. Combining like terms, that gives me 109. T equals 199. Then I can divide, and I get T equals 1.83 hours. All right, let's try another problem. Okay, here we have John left home and drove at a rate of 45 miles per hour for 20 hours. He stopped for lunch. So he's going, he stops for lunch. Then he drove another 3 hours, so then he's going on at 55 miles per hour. To reach his destination, how many miles did he drive? So his distance before lunch is going to be his rate times this time, and his distance after lunch is going to be his rate times this time. And I want the total. So I'm going to go rate times time equals distance. So here I can just take 45 times 20 plus 55 times 3. And that gives me 900 and 165. So I have 900 plus 165 to get the total distance, which in this case is 1,065 miles. Okay, now we have a train that leaves the train station at 1 p.m. It travels at an average rate of 60 miles per hour. So we have the first train going 60 miles per hour. Train. A high-speed train, call it H, leaves the same station an hour later. It travels an average of 96 miles per hour. So we've got train 1, train 2. The second train follows the same route as the first train on the track parallel to the first. In how many hours will the second train catch up to the first? Okay, I don't know how long the second train has been traveling, but I know that the first train has been traveling that long plus 1 more hour because it got started an hour earlier. I want to know when they're going to catch up, so I want to know when the distances are going to be the same or equal. So I'm going to have 60 times t plus 1, rate times time, and I want to know when it's equal to this distance, which is this rate times time. Here I'm going to distribute, which gives me 60t plus 60 equals 96t. Subtract 60t from both sides. And I'm going to get 36t equals 60. Divide both sides by 36. I get t equals 1.6 hours. So it will take the second train 1.6 hours to catch up with the first. All right, let's get a new one. Okay. Noya drives into the city to buy a software program at a computer store. Because the traffic conditions, she averages only 15 miles per hour. So her rate's 15 miles per hour going into the city. On her drive home, she averages 35 miles per hour. We don't know how far we're going. We just know that these are equal. They're the same because she's going there and she's turning around and coming back. Okay, and then all we know about our time is the total time was 2 hours. So I don't know how long it took to get there. We'll call that t. But I know that the time it took her to get back was 2 hours minus however long it took her to get there. All right, and I know these are going to be equal. So I'm going to set them equal. Rate times time. So 15t equals 35 times 2 minus t. Distribute, and I'll get 70 minus 35t equals 15t. Add 35t to both sides, and we're going to get 50t equals 70. Divide both sides by 50. I'm going to get t equals 1.4 hours. Okay, and it says t was how long it took us to get there. That's what it's asking. It's how long does it take her to get here. So we're going to say 1.4 hours. If it then asked us how long it took her to get back, we would have to plug it in here and take 2 minus 1.4 and get 0.6 hours. That's how long it took her to get back. All right, example 5. And now we're moving on to rate times time equals work. Same idea. So suppose one painter can paint an entire house in 12 hours. So his rate is he paints 1/12 of the house per hour. And the second painter takes 8 hours. So it's 1/8. This is rate. How long will it take the two painters to paint the house together? Okay, their time's going to be the same. It's because they're going to finish at the same time. And they're both working to paint one house. So I have 1/12 t plus 1/8 t equals one whole house. Combining like terms here, I'm going to have 5 over 24t. You can just type these fractions into your calculator. Equals 1. Remember to get rid of the 5 over 24. We multiply both sides by 24 over 5. So t equals 24 over 5. 24 divided by 5 is 4.8 hours. So it will take them 4.8 hours together. All right, very similar. Suppose that it takes Janet 6 hours to paint her room if she works alone, and it takes Carl 4 hours to paint the same room. Sorry, Carol. 4 hours to paint the same room if she works alone. How long will it take them to paint the room if they work together? So we have Janet and Carol. Janet's rate is 1/6. Carol's rate, because it takes her 4 hours, so she paints 1/4 of a room per hour. They're going to work together. The time's going to be the same, and we want to know when they're going to get one room painted. So I have 1/6 t plus 1/4 t equals 1. Adding my fractions, I'm going to get 5/12 t equals 1. Remember, you can just multiply by 12 over 5. Multiply by 12 over 5. And we get t equals 12/5, which is 2.4 hours if they work together. Okay, we have one more example. It says, one garden hose can fill the average above ground pool in 10 hours. That makes our rate 1/10. A second hose, so this is the first one. This is the second. Second hose can fill the pool twice as fast as the first, so 2 times this amount. 2 times 1/10. Would you leave as 2/10 or as 1/5 if you want to reduce it? And if both hoses were used together to fill a pool, so they're filling one pool, how long will it take? They're working for the same amount of time. So we have 1/10 t plus, you can just leave this 2/10 t. It'll actually make it a little nicer for us, because then I know that that is 3/10 t equals 1. Multiply by 10 over 3. We get t equals 10/3, or about 3.3 hours. So it will take the two hoses 3.3 hours to fill the pool together. All right, and those are rate time and distance and rate time at work problems. Please let me know if you need any help with 3.3.